So far in this course, we have been working with the built-in file stream, store and sync connectors that come bundled with Kafka Connect. Those are great for learning because they work out of the box. However, in real production environments, you almost never use the file stream connectors. Instead, you will be connecting to databases, cloud storage, search engines, messaging systems, data warehouses, and many other external systems. Kafka Connect doesn't include all of these connectors by default. Instead, it uses a plugin architecture, allowing you to install only the connectors that your environment needs. In this lesson, you will learn how Kafka Connect discover connector plugins, how to configure the plugin path, how to install connector jar files, and finally, how to verify that the installation was successful. This diagram shows how the plugin architecture works inside Kafka Connect. Starting from the left, we have the Connect worker. When a worker starts, one of the very first things it does is scan the configure plugin path. Think of the plugin path as the folder that contains all available connectors. The worker isn't hard-coded with knowledge about JDBC, Elasticsearch, S3, or any other connector. Instead, it discovers them dynamically. Inside the plugin path, each connector has its own directory. In this example, we have a JDBC connector directory, an Elasticsearch connector directory, and an S3 connector directory. Each directory contains the connector jar itself, along with every dependency that connector requires. For example, the JDBC connector contains the connector implementation plus the MySQL JDBC driver. The Elasticsearch connector contains the connector plus the Elasticsearch client libraries. Likewise, the S3 connector contains the connector and the AWS SDK library. When the worker finishes scanning these directories, it loads each connector independently and registers it as an available plugin. One important design decision here is that Kafka Connect isolates each connector using its own class loader. This means if two connectors require different versions of the same Java library, they usually won't interfere with each other because each connector loads its own dependency independently. This isolation is one of the reasons Kafka Connect can support such a large ecosystem of third-party connectors without constantly running into dependency conflicts. Before Kafka Connect can discover any connectors, we need to tell it where to look. That's what the plugin.path property is for inside the worker configuration. In the simplest case, we configure a single directory, such as App Kafka plugins. Whenever the worker starts, it scans this directory looking for connector plugins. You can also specify multiple directories by separating them with commas. This is useful when different teams manage their own connectors, or when you want to keep vendor connectors separate from internally developed connectors. For example, one directory might contain official Confluent connectors, another might contain custom connectors developed by your organization, while a third contains experimental plugins. The worker simply scans every directory listed in the plugin.path and compiles all discovered connectors into a single plugin registry. The directory structure is extremely important. Notice every connector has its own dedicated directory. For example, the JDBC connector has its own folder containing the connector jar, the MySQL driver, and the Postgres driver. The Elasticsearch connector has its own folder with its connector jar and Elasticsearch client libraries. Likewise, the S3 connector has its own directory containing all of its required AWS library. This separation is highly recommended because Kafka Connect treats each directory as an isolated plugin. If you simply copy hundreds of jar files into one large folder, different connectors could accidentally load incompatible versions of the same library. By giving each connector its own directory, Kafka Connect creates an isolated class loader for that connector, greatly reducing dependency conflicts. As a general rule, every connector directory should contain the connector itself plus every dependency it needs to run successfully. Let's walk through the installation process using the JDBC connector as an example. The first step is downloading the connector. One option is to use Confluent Hub, which we will discuss shortly. Alternatively, you can manually download the connector zip file from the vendor or GitHub releases. After downloading the archive, we simply extract it into our configure plugin directory. Once extracted, Kafka Connect now has the connector files available, although we are not quite finished yet because some connectors require additional dependencies. The JDBC connector is a perfect example of a connector that requires additional dependencies. Although the connector knows how to communicate with databases through JDBC, it still needs the specific database driver. For MySQL, we download the MySQL JDBC driver. For Postgres, we download the Postgres JDBC driver. If you wanted to connect to Oracle or SQL Server, you would add their respective JDBC driver as well. The driver jars are simply copied into the same connector directory. Once everything is in place, we restart the Kafka Connect workers. Remember, Kafka Connect scans the plugin path only during startup. Simply copying new jar files into the directory won't make them available immediately. A restart is required so the worker can discover and load the newly installed connector. This sequence diagram shows exactly what happens internally when a worker starts. The process begins with the worker scanning every configured plugin directory. The plugin path then returns every connector jar that it discovers. Next, the worker loads the connector classes into isolated class loaders. Again, this isolation is important because it allows different connectors to use different library versions without interfering with each other. Once the classes are successfully loaded, Kafka Connect registers those connectors internally. Finally, the worker exposes the available connectors through its REST API. This is why after installing a new connector and restarting the worker, you can immediately see it listed through the REST endpoint. After installing a connector, it's always a good idea to verify Kafka Connect actually discovered it. We can call the /connector-plugins REST endpoint. The response contains every connector currently available to the worker. For each connector, we'll see its implementation class, whether it's a source or sink connectors, and the connector version. For example, we might see the built-in file stream connectors alongside the newly installed JDBC source and JDBC sink connectors. If your connector appears in this list, Kafka Connect successfully loaded it and is ready to create connector instances. If it doesn't appear, then something went wrong during installation, configuration, or startup. There are several common problems you will encounter when installing connectors. The first thing to verify is the plugin.path configuration. Next, check that the connector directory actually exists inside one of those configure paths. Also remember, workers must be restarted after installing new plugins. Finally, always inspect the worker logs because class loading errors are usually reported there. Another common issue is dependency conflicts. Errors such as class not found exception or no class def found error often indicate that a required dependency is missing. Make sure every required jar is present inside the connector directory. Avoid mixing multiple connectors into the same directory because isolated directories are specifically designed to reduce those kind of problems. While manual installation works perfectly fine, Confluent Hub makes the process much easier. After installing the Confluent Hub CLI, you simply run a single install command. Confluent Hub automatically downloads the correct connector version, extracts it into the plugin directory, and can even update the worker configuration for you. For beginners, this is often the easiest and safest way to install official connectors because it eliminates much of the manual work. Even experienced administrators frequently use Confluent Hub since it reduces the chance of missing files or installing the wrong version. There are a few best practices worth following from the beginning. First, always keep one directory per connector. Second, Make sure every dependency required by that connector is stored inside its directory. Using version numbers in directory names can also make upgrades much easier to manage. From a version management perspective, avoid replacing existing connectors immediately. Instead, keep previous version available for rollback if an upgrade causes unexpected issues. It's also important to document which connector versions are installed across your environment, and always perform upgrade testing in a staging environment before deploying into production. Following these practices makes maintaining Kafka Connect much easier as the number of connectors grows. Security is another important consideration. Only trusted administrators should have permission to modify the plugin directories. Always download connector jars from trusted sources, such as Confluent Hub, the connector vendor, or official project releases. Many organizations also scan downloaded jar files for known vulnerabilities before deploying them into production. Finally, where possible, verify checksums or digital signatures to ensure the downloaded files haven't been corrupted or tampered with. These simple precautions help protect your Kafka Connect cluster from malicious or compromised plugins. This diagram illustrates a typical production deployment workflow. Everything starts with a central connector repository where approved connector versions are stored. Rather than deploying directly into production, new connector versions are first installed in a staging environment. Comprehensive testing is performed to verify compatibility, functionality, and performance. If the test fails, we fix the issues and repeat the testing process. Only after the connector passes on validation, we begin the deployment to production. Notice we don't update every worker simultaneously. Instead, we perform a rolling update. We update worker 1 first, verify it's healthy, then continue with worker 2 and finally worker 3. This rolling deployment minimizes downtime and reduces deployment risk because only one worker changes at a time. Once every worker has been updated successfully, the entire Kafka Connect cluster is running the new connector version. This stage rollout process is considered a best practice for production environments because it allows problems to be detected early without impacting the entire cluster. Let's summarize what we have learned in this lesson. Kafka Connect discovers connectors by scanning the directories configured in the plugin.path property. Each connector should have its own dedicated directory containing both the connector jar and all of its dependencies. After installing a new connector, workers must be restarted so they can discover and load the new plugin. You can verify successful installation by calling the /connector-plugins REST endpoint and checking that your connector appears in the return list. Finally, tools like Confluent Hub make installing connectors much simpler, while good directory organization, version management, security practices, and stage production deployments help keep Kafka Connect environments reliable and maintainable. In the next lesson, we'll move beyond plugin installation and learn how to manage connectors using the Kafka Connect REST API, including creating, viewing, updating, and deleting connectors.